Hello, welcome back. In this video, I'm going to be going over 3 ACT math questions. For all these problems, I recommend pausing the video and trying the problems yourself first before you see me solve them. Without wasting any time, let's get into it. Question 37 says, a circle with radius 4 centimeters is inscribed in a square as shown below. Which of the following represents the area in square centimeters of the shaded region? So it's talking about this, right? This is our shaded region. And we're also told that a circle is inscribed inside of a square. So it looks like that to find the area of the shaded region, you're going to find the area of the square, right? And subtract that from the area of the circle. So to find the area of the circle, we're going to use the formula pi r squared. In this case, it's given that the radius of the circle is 4 centimeters. So to find the area, it's going to be pi 4 squared. 16 pi is the area of the circle. Now we need to find the area of the square, and we should subtract 16 pi from the area of the square to find the area of the shaded region. If the radius of the circle is 4 centimeters, that means the diameter is 8, right? This is also 4 centimeters, so that means it has to be 8 centimeters. And now we can figure out the area of the square. Because all these other sides are 8. Right? And to find the area of the square, you just take the side length and you multiply it by itself. So you get 64. And the answer is going to be 64 minus the area of the circle, 16 pi, which matches answer choice D. Question 53, which says that given that C does not equal D, it asks, what are all the real values of B that make the inequality BC minus BD over 6C minus 6D less than 0 true? So for this equation, for this question, what I would do is I would try to get B by itself. That would be my first step. So if you look closely here, you can see that in the numerator, B is common, and in the denominator, 6 is common, right? 6C minus 6D and BC minus BD. So let's factor out B from the numerator. And let's factor out 6 from the denominator. And you get this. And now the C minus D, it just cancels out, right? Because it's both in the numerator and the denominator. So it cancels out. You get B over 6 is less than 0. And now if we solve for B, we can just multiply 6, right, to both sides. And you get B is less than 0 because 6 times 0 is 0. And B over 6 times 6 is just B. B is less than 0. So that means it should be all real negative numbers, right? Which matches answer choice E. And yeah, on to the last question. Question 57, which says, for what positive real value of K, if any, is the determinant of the matrix K4, 3K equal to K? And it's given that the determinant of the matrix equals AD minus BC. So for this question, all you have to do is basically you just have to use this formula. So for this matrix, the determinant would be K for 3K. So it's K squared, right? AD minus BC. So you have K squared minus 12, and that equals K, because it says equal to K. So now, if you notice, this just looks exactly like a quadratic equation. So you can subtract K from the right side, and this becomes K squared minus K minus 12 equals 0. And now, if we factor this, this can be broken into, I think, K minus 4 and K plus 3. Let me just double check. Yep, that's right. K minus 4 and K plus 3. This can be factored into that. And if we solve for K, we get K equals 4, right? Because we can set K minus 4 equal to 0. This is one of the factors. K plus 3 equal to 0. And if we solve for K, we get K equals 4. K equals -3. These are your factors. And to find the roots, you have to set the factors equal to 0. So K equals 4 and -3. Right. And let's look at the answer choices. We had K equals 4, so that means the answer to this question is B. I hope my explanations made sense, and thank you for watching.